Alright, so what we did was we did conic sections of cones.
They're the saviors of the world. How? Why?
Alright, so what are conic sections? Conic sections are formed when a plane intersects a cone. The union of the cone to the plane is a conic section itself. Depending on the type of conic section, a different shape is formed in the union of the cone and the plane, and the resulting graph is different for each section. To visualize this, these two pictures of two cones are perpendicular to each other and share a common vertex, as shown in the picture here. There are no finite base to the cones as they extend forever in opposite directions. Alright, so what are conic sections used to calculate? There are four main conic sections, which are circle, ellipse, and a circle is actually a type of ellipse, parabola, and a hyperbola. We will learn about each of these later in the presentation. Conic sections are used to calculate the eccentricity of the section and graph what it looks like. First, the eccentricity of a section is defined as how much the graph of the shape deviates from a circle. We use conic sections to find the exact measure of the eccentricity of each figure. Secondly, conic sections are used for graphing based on the eccentricity and dimensions of the cone. An equation can be used to graph the figure onto a coordinate plane.
What are the differences between the four conic sections? The four conic sections are different from each other by the way a plane intersects the cone. In a cone, the line passing through the vertex of the cone and the center of the bases is the general altitude of the cone. Each conic section is different by how the plane intersects the cone in relation to the altitude. The intersection and angle of the plane compared to the altitude is what forms the four different types of conic sections.
Alright, who discovered the conic sections principle? The first person believed to have studied and devised a conic section principle was Manichmus, who died in the year 320 BC. There are no physical records from that time, but it is known that the definition of conic sections then was based on the angle measure of the vertex, instead of the angle of the intersecting plane. It was said that if the measure of the vertex of the cone was acute, then the section was an ellipse. If it was right, so at 90 degrees, then the intersection formed a parabola. If the vertex was obtuse, then the shape was a hyperbola. This theory is rejected now, since a circle has not yet been considered a conic section, and a circle is unable to be formed through these conditions. The person credited with finding the correct and current principle of the conic sections is Apollonius of Perga, died in 190 BC, who wrote an 8-volume series entitled Conic Sections that presented and enlarged the current knowledge of conic sections.
What do the graphs of the conic sections look like? We will not explain here how to graph the four conic sections, but to the right is an image of all four conic sections and what they look like when plotted onto an x and y axis graph. The circle is top left, the ellipse is top right, parabola bottom left, and hyperbola is bottom right. The lines separating the four images do not represent the axis.
An ellipse. The ellipse conic section is formed when the plane of a cone intercepts only one nap of a cone. A nap is one side of the cone, either the portion above the vertex or the portion below. The section basically looks like an oval or a stretched circle. The plane is on an angle compared to the altitude, and the eccentricity for an ellipse is always either greater than 0 or less than 1. The exact eccentricity is found by the equation, which is the square root of 1 minus b squared over a squared. An ellipse is always be a two-dimensional closed shape with a definite area. The equation for graphing an ellipse is a squared, x squared over a squared, plus y squared over b squared is equal to 1. A is equal to the x-intercept, and b is equal to the y-intercept.
Circle. The circle conic section is a special type of ellipse. For a circle, the intersecting plane is perpendicular to the altitude. Since conic sections deal with right circular cones, the circle conic section is a cross-section of the cone. Cross-sections are similar to the base of the solid to which they are part of, and since cones possess a circular base, then the shape formed is always a circle as well. A circle is a set of all points that are equidistant from a single center point. The eccentricity of a circle is 0, since it obviously does not deviate from the circle. The equation to graph a circle is x squared plus y squared equals r squared, or x minus h squared plus y minus k squared when 0, 0 is not set.
Alright, a parabola. A parabolic conic section is formed when the plane intercepts only one nap of a cone, similar to an ellipse. The difference with a parabola and an ellipse, however, is that the eccentricity of the two is not the same, and a parabola is not a closed figure. Therefore, it has no definite volume. A parabola looks like a U shape when graphed. The eccentricity of a parabola is always exactly 1. And the equation for how to graph a parabola is y squared is equal to 4px, or x squared is equal to 4py. And y is equal to ax squared plus bx plus c, when 0, 0 isn't the focus.
Hyperbola. A hyperbola is similar to a parabola in the way that neither have a definite volume and are open figures. Hyperbolas look like two V-shapes on a graph that are mirror images of each other across an axis, x or y. The diagonal lines formed from the equation y equals x and y equals negative x are called asymptotes, which are the red lines here in this diagram. The plane of a hyperbola or conic section is always parallel to the altitude of the cone. Hyperbolas start from a common point and extend closer and closer to these asymptotes, but never intersect them, as seen in the picture here. Hyperbolas on either side of the x-axis are called north-south hyperbolas, while ones on either side of the y-axis are called east-west. The eccentricity of a hyperbola is always greater than 1 and can be found with the equation the eccentricity equals √1 plus b squared over a squared. The equation for how to graph a north-south hyperbola is x squared over a squared minus y squared over b squared is equal to 1. And the equation for how to graph an east-west hyperbola is y squared over a squared minus x squared over b squared is equal to 1.
Yeah.
Alright.